Hi guys, this is Dr. Kruse. We're going to talk about functions, specifically functions that come from an equation. But let's back up real quick and let's review rounding. All right, we're going to do a little rounding review, and then we'll kind of work our way to how to deal with functions, because lots of times in a function, you're going to get a number that goes on forever like this, like e. This is called Euler's number. And it's going to ask you to round to 2 or 3 or 4 decimal places. So let's practice that. First of all, just real quick, let me tell you where this number came from. This is Euler's number, E-U-L-E-R. Looks like Euler, but you say it Euler. And he came up with this magical irrational number that we use for exponential growth a lot. Now, where is that on your calculator? Well, on the 84 plus. It's right here above the natural log button. Now, let me talk about the functions. Since we're talking about functions, each one of these buttons has 3 functions. If you press this button, it's a natural log button. But if you switch to the blue, it's that E number, that Euler's number. And then if you switch to the green function, then it's an S. All right, so 3 functions. It's either a natural log, or it's an E, or it's the letter S. It just depends on which function you want to use. All right, so this button works in 3 different ways. It has 3 functions. I want to use the E function. Now that's in blue. That's my second function. So I'm going to hit the blue key and then the natural log button. But since I hit the blue key first, it's going to be doing the blue function. So I'm going to do second and then the natural log button, which pulls up. Oh man, it helps if you turn it on. Second, natural log, and it pulls up the E. Now it's asking for an exponent. It says, hey, what do you want to round this to? Well, I just want to look at regular old E. So I'm just going to raise it to the first power. And there it is. Okay, on the TI-83, it's in the same place. All right, just different colors. I got my natural log button, which does 3 functions. If you press it now, it's natural log. If you press the yellow button first, we use the second function, which is E. And if you press the green button first, it uses the third function, which is the letter S. Okay, I want the second function. So I'm going to do yellow natural log, or second function natural log. So second function natural log pulls up this E. All right. This is how the TI-83 raises something to an exponent. That little boomerang there, it's saying E raised up to, and now here they want that exponent. We're just going to raise it to the first power and close that parentheses. And E to the first power is right there. All right, so that's a quick lesson on Euler's number, where it is on your calculator. Now, if we want to round this to 2 decimal places, when they say 2 decimal places, what they're saying is they want 2 numbers after the decimal. 2 numbers after the decimal. So here's my decimal. They want the 7 and the 1. So I'm tempted to write 2.71 as my answer, rounded to 2 places after the decimal. But let's just cover that up here. Oh, I'm on the struggle bus. There we go. So if I just keep the 2 numbers after the decimal, it looks like my answer is 2.71. All right, sounds like I'm following the rules. Sounds like that's the answer. But I got to peek at that next number right there just to see if it's going to round that 1 up. So it looks like my answer is 2.71, but I peek at the next number, that 8, if that's 5 or bigger, you got to round this guy up. So we got to round that up to 2 because this is 5 or bigger. So my actual answer is not 2.71, it's 2.72. All right, let's say we're going to round to 3 decimal places. Well, that's 2 point, and I want to keep these 3 numbers, 718. All right, so it looks like my answer is 2.718 if I round it to 3 decimal places. But before you write it down, just take a peek at that next number. Oh, that's a 2, all right? If it's a 5 or bigger, it's going to round that 8 up to a 9, but that's not bigger than 5. So this guy stays 8. So rounded to 1, 2, 3 places after the decimal, it's 2.718 and so on. Let's go one more time. Let's go 4 decimal places. Looks like it's 2.7182, but don't write it down yet. You got to check this number right here. So let's take a peek. Whoop, that's an 8. That's 5 or bigger. I got to round this up to a 3. So rounded to 4 decimal places. There's the decimal. There's 1, 2, 3, 4 numbers after the decimal. It's going to be 2.718, and I got to round that up to 3 because the next number is bigger than 5. All right, next we got to talk about how to enter fractions correctly, all right? Because lots of our functions, that we're going to talk about today are in the form of fractions. And the order of operations, well, if we just put it in left to right and put in 4 plus 5 divided by 1 plus 2 like this, we're going to get 11, which is the wrong answer. All right, we kind of broke the rule. With fractions, you actually want to get one number on top, that's 9, 4 plus 5 is 9, and one number on bottom, that's 3. So what this problem actually says is 9 divided by 3 is what we want the calculator to do for us. All right, there's a couple of ways to do it, just depending on where, which calculator you're using. If I'm using the 83 plus, kind of the older model, I have to tell it with parentheses that I want to do the top first, because parentheses is the first thing we do in order of operations. So tell the calculator you need to add these parentheses. If you're using an 83, add these parentheses and tell the calculator, okay, do the top first, that's 9. And then you have to add these parentheses on bottom to tell it to do that next. 1 plus 2, that's 3. And then the last thing it will do is divide. 9 divided by 3 is 3. All right? So you're going to have to add. Anytime you have a fraction on the 83 plus, you're going to have to make sure every time you have a fraction, you put parentheses around the top and parentheses around the bottom so that it does your math right. Okay, and here's what it's going to look like on your calculator. So you're saying, hey, group the 4 and 5 together. This is the top. That's going to be 9. Group the bottom together. That's 3. And then that's what your division symbol looks like. Because on the 83, it doesn't really look like a fraction. We're just going to use, instead of the fraction bar, we're going to use a division symbol. Now, on the 84, it's a little easier to put fractions in, which is one reason I kind of like the 84 plus a little bit better, because I don't have to mess with these parentheses. I can pull up a picture of a fraction and just put in the numbers on top and bottom. Now, the picture is hiding right here in F1, all right? That's green. That's the third function of this button. The first function is y equals, the blue function is stat plot, the green function is F1, and I remember F for fraction. So if I want to put in a picture of a fraction, I need that F1. So I need to do the third function of this button. So I'm going to hit the green, the third function. So green, F1, and that pulls up this menu here. I want the first one. I want a picture of a numerator over a denominator. So I choose 1, and there's your picture. And now all you got to do is put 4 plus 5 on top, and then just use your arrow key, arrow down, 1 plus 2 on bottom, and it's a little easier than the 83. All right, there's your instructions if you want to write them down. To get this, I have to go to the F1 key. It's green, so you got to hit the green alpha button first. Green, F1, choose option 1, picture of a fraction, and it brings up a picture. All right, so now let's get into functions. Let's talk about back in junior high. All right, you had nice simple equations like this. You guys remember when you were graphing in junior high? It said something like y equals mx plus b, and this is where it crossed the y-axis, and this is the slope that went 3 steps up and 4 steps over. Well, we're not graphing today, but that's the kind of equation you dealt with in junior high. And we're going to do the same kind of equation, only we're going to speak function. All right, we're in college now, so we're going to speak using function notation. Even though it's the same equation, instead of saying y, I'm going to say this is the function which I've named f. We could call it g, we could call it h, we could call it a lot of things. But if you don't have a name for it or you don't have a story problem to go with it, we just call it f. So this is the function that I've named f. All right. And the function, when I put a number in for x, turns out to be whatever this works out to be when I replace x with a number. So I said the function, when I replace x with a number, is, and then I replace x with a number and work it out. In other words, I'm saying y is whatever this works out to be. We're going to put in the x, and y is whatever pops out when that's done. We're going to put in the x here, and f of x is going to be whatever pops out when it's done. Y and f of x are the same thing. This is function notation. We're just kind of speaking a different language. All right, lots of ways to say it. You can say f in terms of x is, and then whatever your expression is. Lots of teachers just skip the in terms, and they just say f of x is your expression. So f of x is probably what you heard in high school. A fancier way to say it is f in terms of x. All right, what about f of 4? Well, if I say, what's f of 4? I'm saying, well, what is y if x is 4? See, here's the original function. F of x, or y, is 3/4 times x plus 5. If I say f of 4, I'm saying, okay, if I replace the x with a 4, what does my function produce? This is the input. I'm going to put in 4 for x, and I'm going to see what happens. So the function f in terms of 4, or the function f when I put a 4 in for x, is 3/4 times 4. See, I'm putting the 4 in for x, plus 5. That's going to work out to be 8. This is your x. Whatever's in the parentheses, that's your x number. That's your input. This is your y. This is your output. So 4 went in, 8 came out. X went in, y came out. Input, output. So think of x and y as a pair, all right? Same thing up here. We put 4 in for x, and y turned out to be 8, all right? If 4 is x, then y is 8. It's all the same thing. We're just writing it a little bit differently now, all right? This is your x, this is your y. So how would we say it? How would we talk the talk? We'd say, oh, f in terms of 4 is 8. We could say f in terms of 4 is 8. Or we could say f of 4 is 8. Or we could say the function named f, when x is 4, produced 8. See, there's lots of ways to say it. But what you think in your head is, okay, when x is 4, y is 8. We're going to think of that as an ordered pair. When x is 4, y turns out to be 8. If we put 4 into the function, it spits out an 8 for the y. X goes in, y comes out. All right, let's try a new function. So I've named this function f. I could have said g of x or h of x or whatever letter I want. This letter is just the name of the function. So f of x this time, or f in terms of x, is the root of x plus 2 all over x squared plus 3. All right, looks a little scary. It's not. We're just going to plug a number in for x and work it out. So maybe I want to know what this function is when or at x equals 7. I want to calculate f of 7. I want to know what the function produces when x is 7. All right, here's what it's going to look like. All right, f of 7, we're replacing the x with 7. F of 7 is, and then look, I have the exact same thing down here, but I changed this x to 7, and I changed this x to 7. Now, all the red parentheses is kind of what you need to add when you're working with a TI-83. It's a little bit harder, but that's okay. Remember, I've already told you about this parentheses and this one. Anytime you have a fraction on an 83, you have to group the top with the parentheses here and the parentheses there. And you have to group the numbers on the bottom with the parentheses here and the parentheses there. So we already knew about that. Why do we have these extra parentheses? Well, on the 83, when you start a root, it's automatically going to start a parentheses right there. And it's going to say, okay, I'm going to start square rooting right here, but you have to tell me when to stop square rooting. So we have to add those parentheses. It's going to start rooting here, and after the 2, we have to put a parentheses to tell it to stop rooting. On the bottom, it's just a good idea whenever you're squaring a number, it's a good idea on the 83 to go ahead and enclose that number in parentheses, just in case it's a negative. All right, if it's a negative, we want this to square properly, so that negative needs to be inside the parentheses with the 7. All right, so let's see if I can do this on the 83 here. I want to start with a parentheses on the top. I'm doing this parentheses right here. Now I'm going to open the root. Now the root is above your x squared key on the left. It's the second function of your x squared key. So when I opened up the root, it automatically opened this parentheses here, and it says, okay, I'm going to start rooting right here, and I need to tell it to stop square rooting after the 2. So 7 plus 2. Now I'm telling it stop square rooting. All right, that's what it looks like on the 83. It's going to root this group here, 7 plus 2. It starts rooting here and it stops rooting there. Now don't forget, I have to close this parentheses as well, because this is the beginning of the top. I'm telling you, this is the top of the fraction, so I need to close that one as well. Anytime you open a parentheses, you have to close it. All right, so the top starts here and the top stops there. The root starts here and the root stops there. That's the top. Now I'm going to hit divided by, and now I move to the bottom. Okay, on the bottom, I have to start the bottom, parentheses, and I need to start the square. Anytime you square a number, you need to enclose that number in parentheses. So I'm going to enclose the 7 in parentheses. Now I'm going to use this boomerang button right over here on the 83 to raise it to a power. That little boomerang looking button, that's how we raise it to the second power. So here's where I'm at right now. I started the bottom, I started the square, there's 7, I stopped the square, I actually squared it, I raised it to the second power. Now I need a plus 3, and then finally I just have to close the bottom. If you open the bottom, you got to close the bottom. If you open the square, you got to close the square. So I close that and hit enter, and there's my answer right there. Now, I'm just going to tell you, let's round it to 2 decimal places. That's usually what we round it to. So remember how to round. You got to cover up everything except 2 numbers after the decimal. There we go. So it looks like the answer is 0.05, but take a peek at that next number. Oh, that's 7. That's bigger than 5. I got to round that up. So it's actually 0.06. All right. So talk in function notation here. You're going to say, okay, f, the function f, the function that we've named f, when I put 7 in for x, produces 0.06. I have to go through all this math here, but that's what happened. When I put 7 in for x, y turns out to be 0.06. F of 7 is 0.06. Think of it as an ordered pair. Just think of it as the ordered pair 7, 0.06, which later on we'll graph. We're not graphing today. Okay, so let's just review what we're doing. When they say, what is this function at x equals 7? They're saying, calculate the function replacing x with 7. So what they're asking is, if I give you x, which is 7, what's y? That's what they're asking. I'm going to give you x, tell me what y is. Well, you just got to plug in x, and it pops out. Now remember, y and f of x are the same thing. Now if I put in 7, then what's f of 7? I got to work that out. I got to put the 7 in, and I got to do the math. So when I put in 7 for x, what do I get? That's what this is asking. All right, what is f of 7? They're saying, what is y when x is 7? Okay, let me show you how much easier it is on the 84. So I'm going to pull up my fraction key. Remember, it's in F1. It's in the third function of this button. So I got to hit green, F1, choose option 1 for fraction. There we go. And now I'm going to start putting in my fraction. All right, root's right there above the x squared key. So that's blue, second root. All right. Now this is easier on the 84 because I don't have to use parentheses under the root. I can just type in what's under the root, 7 plus 2. Now if I need to get out of the root, I just go one step to the right using my arrow keys, and now I'm outside the root. Let's arrow down to the bottom, and on the bottom I got 7. I'm going to square it. Here's your squared button, by the way, on the left, x squared. And then I want to add 3, and I get a fraction. Okay, that's my answer. Now, I was kind of looking for a decimal answer. Lots of times they'll ask you for a decimal answer. I just need to change this fraction to a decimal, and that's real easy. It's in the math menu right here, math. And it says, what do you want to do? Well, I actually want option number 2. I want to change my answer to a decimal. All right. Option 1 says, do you want to change your answer to a fraction? Option 2 says, do you want to change your answer to a decimal? I want option 2. And it says, are you sure? Yes. So I'm going to hit enter one more time. And there's the same answer, 0.06 rounded to 2 decimal places. All right, let's talk about a function that calculates the cost of a movie ticket in a certain year. Like back when I was a kid, it only cost $1 or $2 to go to a movie. But nowadays it costs you $8, $10, whatever. So the cost kind of depends on what year we're talking about. Now to write this in function notation, I'm going to use C for cost. So I'm going to name my function C because that's a nice handy letter that goes with my problem. Now usually I would use Y for year, but we don't like to use X and Y because we use those with ordered pairs and stuff. So avoid using X and Y in your names. Instead of year, we're just going to say, hey, that's time. Let's use T for the letter time, okay? So cost, C, depends on time, T, all right? Or what year it is. We're just not going to use Y for year. C depends on T. So the cost of a movie ticket depends on what year it is or how many years have gone by. C depends on T. C of T, C with respect to T. See, we're just learning to talk another language. Okay, we can say it all these ways. C in terms of T, C with respect to T, C of T. All right, so maybe you come up with a problem like this, and they give you a formula. Remember, the title of this lesson was Functions when given a formula. So the cost of a movie ticket depends on the year you're talking about, depends on how much time has gone by. And the initial formula is $5.80 for a ticket plus 23 cents for every year that's gone by. All right, so our starting point is $5.80, but it goes up 23 cents for every year that's gone by. Now, lots of times they'll give you a starting point, and this one here they say T is the number of years since the year 2000. So our starting point is the year 2000. So when we're trying to figure out how much time has gone by or what year it is, remember they started this formula, they started this measurement in the year 2000. That was the beginning. All right, it says use functional notation to express movie cost in 2011. Okay, let's think about that. They started this formula in 2000. They started this observation, this experiment in the year 2000. This would be 11 years later. So T is going to be 11. T is how long has it been since the beginning. The cost of a ticket 11 years later is $5.80 plus 0.23 times 11. T is the number of years since the beginning, since 2000. Okay. So if they say something like use functional notation to express the movie cost in 2011, you're going to say, okay, the cost in terms of 11 years later, or the cost of a movie ticket depends on 11 years passing. X is 11. That's the number that's going to go in the parentheses. That's going to be our X. After we work this out pops the Y. All right, so calculate that cost. They're just saying, okay, 11 years later, how much was that cost? They're asking for the Y. So the cost of a movie ticket 11 years after we started measuring is $5.80 plus 23 cents times 11 years. The cost of a movie ticket in terms of 11 years later is $8.33. So if X is 11, Y is 8.33. X is the input, Y is the output. X goes in, whatever's in the parentheses, that's what's going in. And we replace X with X with 11. And then whatever the calculation is, whatever pops out, that's Y, that's the output. All right, let's do one more problem here. Maybe the problem says, hey, we introduced some deer into a forest, in a certain year. And let's come up with a function that explains, what happened. Because the deer are going to breed, they're going to multiply. That herd is going to get larger as years go by, as time goes by. So write a function for the number of deer in a certain year. Well, we can use n for number. That's a nice letter. Just stay away from x's and y's. N is fine for number. Remember, we like to stay away from x's and y's. So instead of year, we're going to use time, T for time. And it's going to stand for the time since the herd was introduced, since they dropped off those deer in the forest. So the number of deer depends on how much time has gone by since the beginning. And usually they'll tell you when the beginning was. So here's your function, n of t. The number of deer depends on how many years have gone by. And it's expressed by this formula here. So now once they tell us how many years have gone by, we can put that number in for t right there as an exponent, and we can calculate how many deer we have. Okay, here's kind of a brain teaser. Lots of times they'll ask you, well, how many deer did you start with? How many deer were initially on the reserve? Initially means at the beginning. Like, maybe they brought them out there in a cattle trailer or something like that, and they dumped them in the forest. Well, how many deer did you initially dump in the forest? Okay, initial you got to think about how much time has gone by. Remember, T is the time since the herd was introduced. Well, if you have just dropped them off out of the cattle trailer, then time is 0. No time has gone by. All right, we just dropped them off out of the trailer. They haven't had time to breed or multiply or reproduce or anything like that. So whenever they ask you for the initial amount, they're saying when time is 0, when no time has elapsed, how much did you have? Okay, so if I know that no time has elapsed, I just go back to my formula in here and I go, okay, I wonder how many deer I had when no time had passed. What's the number of deer with respect to 0 time passing? 12.37 divided by 0.03 plus 0.54 raised to the 0. That's what I'm going to do. I'm just going to change t to 0 and work it out. I mean, I could put in, 1 year later, 2 years later, 3 years later, but what they asked was how much did you have at the start? Before, at the very beginning of the experiment, when we started measuring, the number of deer when no years had passed, when no time had gone by, is this expression replacing t with 0. And we end up with 12 deer. All right, so the number of deer when no time had passed is 12. 0 is x, 12 is y. Think of it as an ordered pair. Remember, always think of this as an ordered pair, 0, 12. If I was going to graph this, this tells me don't go left or right, and this number tells me just go 12 steps up. Well, if you guys think about that, you guys remember graphing from junior high and high school. If you don't go left or right and you just go 12 steps up, you're on the y-axis. This is the y-intercept from junior high, all right? When they ask you for the initial value or how many you started with, they're just asking you for the y-intercept. When x is 0, you go a certain number of steps up, that's where your line or your curve is going to cross the y-axis. The good old y-intercept from junior high. All right, guys, that's all I got for today.